Today's lesson will describe some ways that oxidation numbers are used, including balancing equations. Recall from yesterday's lesson that reduction involves gaining electrons. When an atom gains electrons, its oxidation number will decrease. Oxidation involves losing electrons. When an atom loses electrons, its oxidation number will increase. There are two related terms that you must also understand. A reducing agent is an entity that causes reduction in another entity. A reducing agent is oxidized. An oxidizing agent is an entity that causes oxidation in another entity. An oxidizing agent is reduced. It can be very easy to confuse these terms, so be very careful when you read through your problems. This is the same diagram that you would have seen yesterday. See how the reducing agent is losing electrons through the process of oxidation. The oxidizing agent is gaining electrons through the process of reduction. There are a number of ways that we can use oxidation numbers. We can use a change in oxidation number to show us if a reaction that has taken place is a redox reaction. If the oxidation numbers change, then reduction and oxidation have taken place. If the oxidation numbers do not change, then no redox reaction has occurred. We can also use oxidation numbers to tell us which entity is oxidizing and which entity is reducing in a chemical reaction. An increase in oxidation number means that oxidation has taken place. A decrease in the oxidation number means that reduction has taken place. In this example, we are able to determine which entity undergoes reduction and which entity undergoes oxidation. We need to begin by determining the oxidation number of each atom in the balanced equation. Here you can see the oxidation number goes up for carbon, so it represents the oxidation in the redox reaction. The oxygen has a lower oxidation number on the product side, so it represents the reduction part of the redox reaction. Another thing that you will need to use oxidation numbers for is balancing redox reactions. When you have redox reactions, you must balance the reactions in a different way. It is not enough to only balance the atoms. We must use a special procedure to balance the charges as well. There is a very systematic way to balance redox reactions by using oxidation numbers. We must begin by assigning the oxidation number to each atom and ion in the equation. For step 2, we need to look through all the oxidation numbers to see if there are any atoms that increase or decrease in oxidation number. In this example, you can see that carbon has an oxidation number of -2 on the reactant side and an oxidation number of 0 on the product side. This means that there is a change of 2 electrons for each carbon atom. Meanwhile, manganese is changing from an oxidation number of +7 to an oxidation number of +2. This means that there are 5 electrons transferred for each manganese atom. Step 3 becomes important when the chemical formulas for the entities involved in the reaction have more than one atom of the oxidizing agent or the reducing agent. In this example, there is only one carbon in methanol, so there is still a 2 electron transfer per molecule. There's only one manganese atom in the permanganate ion, so there is still a 5 electron transfer per permanganate ion. In step 4, we need to balance the number of electrons that are gained by one entity with the number of electrons lost by the other entity. Here we use the values of 5 and 2 to bring the total electron transfer to 10 in both directions. The values that we use to balance the number of electrons are used as coefficients to balance the reaction. Notice how the 5 and 2 are now written in the reaction equation. It is a step closer to being balanced properly. In acidic conditions, we are going to add water to balance the hydrogen atoms and hydrogen plus ions to balance the hydrogen atoms. Now the atoms and the charges are both accounted for in the balanced equation. Finally, our equation has been balanced. The manganese atoms in this case undergo reduction, and the carbon atoms undergo oxidation. There is an excellent example in your textbook that shows how to approach step 3 when oxidizing agents or reducing agents are present in larger quantities. Please also complete the October 3rd quiz.